Hey Lead Code fam, guess who's back? Today let's solve two sum in what do you tell? Neither too optimal nor too brute force way. In the previous video I showed you how to solve it in the most optimal way using O of n time and O of n space. Now let's solve it in O of n log n time and O of 1 space. Yeah, I know, O of n log n, what you're talking about. How to do it? The idea is again pretty simple, and the good thing about this is there is no requirement to know complex data structures such as dictionaries. So now how can we do it, you ask? I'll tell it. The main ideology is to create a new two-dimensional array which houses the index as the first element and the value as the second element, and then we can directly use some lambda functions or custom comparators to sort the array based on the first index of the new array, and then we can directly use two pointers and some small logic to determine if we have reached our sum. Oh, you tell, how to do that? Okay, let's see that. Again consider the array 10, 5, 15 and 21, and now consider the target 25. So now what we can do is we can create a new array which houses the index as the first element and the value of the index as the second element. So let me just fill it to 1 minute. Now we just sort the array based on the first index. First index, in other words, 10, 15, 10, 5 like that. So what will be the resultant array? 1, 5. And now we can directly use two pointers to check if the target 25 exists in our array. Does 21 plus 5 equal to 25? No, it is 26, which is greater than 25. So we take the right pointer which is placed at the end of the array, yeah, left is here and right is here initially. So now what you do is we decrement the right pointer. Now does 5 and 15 add up to 25? The answer is obviously no, it is lesser than that. So we increment the left pointer, and now does 10 plus 15 add to 25? Oh my god, it does. So what we can do? We can directly return 0 and 2 which we have already stored. And so we have an n log n solution, mainly because n log n for searching and sorting, and for searching it is O of n, and n log n plus n directly computes to O of n log n. So okay, now let's solve the problem. This is the new array which we have declared, and again, as I have explained, enumerate is a way to gracefully iterate to the array. The I and the num as explained. Now what we can do is we can directly sort it, but be careful while sorting because we don't want to sort based on the 0th value, which is default value in sorting. We have to sort it based on the first value, so we use lambda functions. And don't get scared on seeing this expression. This is not doing anything but just telling to use the sort to do the sorting based on the first value. Now what we can do is we can use two pointers, one placed at the end and the other placed at the beginning. And now very small logic which I have already explained. We have to go till left is less than right. At the first index, not the 0th index. Now check if is the sums equal to target, and if it is equal then we have obviously found our solution, so return. At the position 0, sums becomes greater than, then we obviously decrement the right pointer. Else L plus is equal to 1. Now let's check if it works or have I made some dumb mistake. And yes, mistake 1 and mistake 2. This happens to everyone, so don't get disheartened if you can't solve it or anything. And yes, it's pretty obvious that it was not as optimal as the previous solution, but it was not as bad as the brute force solution also. So yeah, if you have any doubts, then please leave a comment, and thank you for watching if you have watched till now. Goodbye.